All right, so welcome back for part 4 of section 2.1. We're going to take a look at an application problem of a system of equations, and then we'll decide whether this is one of those ones where we have a solution or parameterized solutions or many solutions, that kind of thing. All right, so a restaurant owner orders a replacement set of knives, forks, and spoons. The box arrives containing 60 utensils and weighing 189.6 ounces, ignoring the weight of the box. A knife, a fork, and a spoon weigh 3.9, 3.6, and 3.0 ounces respectively. Find the solution to this system with the largest number of spoons. Okay. All right, so it looks like we have 3 unknowns here. We don't know how many knives, we don't know how many forks, we don't know how many spoons, so that implies we have 3 variables. I'm going to call them X will be the number of knives. I'll say that Y will be the number of forks. And then we'll make Z be the number of spoons. And I know the following. I know that X plus Y plus Z is equal to 60 because the box arrived with 60 utensils in it. And then I know something about weight. I know that the weight of the knives, the weight of the forks, and the weight of the spoons has to add up to 189.6 ounces. So that means that the 3.9 ounces times the number of knives plus 3.6 ounces times the number of forks plus 3 ounces times the number of spoons has to add up to 189.6. But since I have 3 variables, I really want 3 equations, but I'm not seeing a third equation in here anywhere. So it looks like I've got a system here with fewer equations than variables, so I know that I'm going to have to parameterize this. All right, so first things first, I'm going to come over here on the right, and I'm going to figure out what I'm looking at here. I'm looking at X plus Y plus Z equals 60. I'm just kind of rewriting to clean things up. I'm looking at 3.9X plus 3.6Y plus 3Z is equal to 189.6. Echelon method would say, do what you got to do to make this go away. So I am going to take equation number 1 and leave it alone. Now you notice I'm spacing that out a little bit because I know that the coefficients in the second equation might be bad. And I am going to take equation number 2 and replace it with equation number 2 minus 3.9 equation 1. So my scratch work over here. Equation number 2, 3.9x plus 3.6y plus 3z equals 189.6. That's a 3, believe it or not, right there. Let me make that a little better. Why wouldn't it erase? Here we go. Minus 3.9 times the first equation, so 3.9x plus 3.9y plus 3.9z is equal to 60 times 3.9. I'm going to grab my calculator and figure out what that is. Let's see, 60 times 3.9 is 234. Well, that's nice. So 234, okay? And so then when I subtract those, that cancels. I get negative 0.3y. I get negative 0.9z is equal to, let's see, 189.6 minus 234 gives me negative 44.4. So, okay, so then my second equation is negative 0.3y minus 0.9z is equal to negative 44.4. So it looks like I'm ready to parameterize, because if I knew z, I could find y in the second equation, then I would know y and z, and I could find x in the first equation. Okay, so I'm going to parameterize this thing. So I'm going to solve that second equation over here in my scratch work again. I'm going to solve that second equation for y in terms of z. So negative 0.3y would be equal to 0.9z minus 44.4. I'm going to divide both sides by that negative 0.3. So I get y equals negative 3z plus, let's see, calculator, 44.4 divided by 0.3 is 148. Okay. All right, so now I'll take that and back substitute in the first equation to pick up x. So now I've got x plus negative 3z plus 148 plus z equals 60. And so that gives me x minus 2z plus 148 equals 60. So x equals 2z minus, let's see, when I take that over, that's going to give me what, negative 88? Okay. So now I've got a parameterized solution. My parameterized solution is 2z minus 88 for x, negative 3z plus 148 for y, and z for z. And so now I'm going to try to figure out what that means in terms of solutions. Okay. Z, x, y, but remember x is 2z minus 88, and y is, I'm going to write it as 148 minus 3z. All right, last time we did this problem, we started out by saying that z is equal to 0, but I can't do that here, because if I do that here, I would get negative 88 here and 148 there, and this is a problem. Because remember, z stood for spoons, x was knives, and y was forks. And we can't have a negative number of knives. So that means I got to think a little bigger here. Z can't be 0. How big does z need to be? Well, judging from the equation right here, the parameterized solution for x, it looks like z needs to be big enough so that 2z minus 88 isn't negative. So it looks like z would have to be at least 44. So that 2z minus 2 times 44 would be 88 minus 88 is 0. And then what will we get down here on the end? Well, 148 minus 3 times 44. Well, what's 3 times 44? 3 times 44 is 132. So 148 minus 132. 148 minus 132 will give me what, 16? So one possible solution is to have 44 spoons, 0 knives, and 16 forks. And now we'll make z be a bigger number. What if z was 45? I don't have to worry about that fraction thing before, so I don't have to go up by 2s or 3s or anything. I can just go up by 1. But 2 times 45 is 90. 90 minus 88 is 2. And then this is going to be, let's see, 45 times 3. Well, 45 times 3 is 135. 148 minus 135 is going to give me 13. Oh, wait a second. The 2 here means these are going to go up by 2, and the negative 3 here means those are going to go down by 3. So if this goes to 46, this will be 4 and this will be 10. And if this goes to 48, this will be 6 and this will be, what is that going to be, 7? And if this, whoa, Brian, made a mistake there. 47, up by 1, up by 2, down by 3. 48, up by 2, down by 3. 49, up by 2, down by 3. And I can't go bigger because if I go to 50 here, this will go negative. So that's bad. So it looks like our system has 1, 2, 3, 4, 5, 6 different possible solutions. But what are we looking for here? We're looking for the solution with the largest number of spoons. And so the largest number of spoons will be 49. So then wrapping it up and making it look pretty. The solution with the largest number of spoons is 49 spoons, 10 knives, and 1 fork. All right. Now, of course, I could go back to the equations and check my work, and actually I just paused the video and did. Plus I wanted to get a drink of water too. But yeah, that is the correct answer. All right, this brings us to the end of section 2.1. Hopefully everything makes sense. If not, please, of course, reach out, ask any questions, send me a message, email me, text me, whatever, if you have any questions or concerns. All right, have a good one.